Wallet design is ultimately a control model. Who holds keys, who approves transactions, and who absorbs risk when something goes wrong. As we compare custody patterns, focus on the core trade-off between security, compliance, operational flexibility, and user trust. You've moved from platform choices to token models and settlement design. Now we shift to the control layer: wallets, custody, and keys. This is where regulated issuance becomes operationally secure, auditable, and ready for real transactions. Wallet and custody architecture functions like the control room for tokenized assets. It is not just where a user clicks send. It defines who can move value, what approvals are required, how keys are protected, and how access is recovered if something goes wrong. It also sets liability boundaries between investors, issuers, platforms, and custodians. If this layer is weak, even strong token design, settlement logic, and compliance rules can fail in practice. Custody is best understood as a spectrum, not a binary choice. At one end, non-custodial wallets give users or institutions direct responsibility for keys, signing, backups, and recovery. At the other end, custodians hold keys and operate transactions under trust, regulation, and service agreements. Between those points are hybrid models: co-signing, policy engines, MPC, multisig, HSMs, and smart contract wallets. Enterprises often combine these approaches to match risk, compliance, participant needs, and operational scale. In a custodial wallet, the user does not directly control the private keys. They submit a request, and the custodian applies identity checks, policy approvals, compliance rules, and signing controls before the transaction reaches the blockchain. This creates a smoother institutional workflow. Recovery is easier, reporting is centralized, and assets can be segregated. The trade-off is trust. The custodian becomes an operational counterparty, so governance, audits, insurance, and oversight become essential. A non-custodial wallet puts signing power directly in the owner's hands. No custodian needs to approve or execute transactions. The benefit is control and reduced intermediary risk. The trade-off is responsibility. Keys must be protected, transactions verified, backups planned, and recovery defined before something goes wrong. Semi-custodial custody splits authority instead of giving full control to one party. A user may initiate a transfer, while execution requires co-signing, policy approval, compliance checks, or a recovery agent. This keeps the investor involved while giving the platform tools to enforce rules and recover access when needed. The main trade-off is legal clarity. Agreements must define who can approve, block, recover, or be liable for each transaction. These models are not interchangeable. Custodial designs give enterprises strong operational control, smoother recovery, and familiar institutional service, but they concentrate trust and liability in a provider. Non-custodial designs maximize participant control, yet demand disciplined key management and make support harder. Hybrid designs can separate roles and balance governance, but they add legal, technical, and integration complexity. In practice, regulated platforms often use more than one model for different participants. MPC wallets replace the idea of one private key with several cryptographic shares held by different devices, services, or partners. To approve a transaction, only a required threshold of shares participates, such as 2 of 3, without ever rebuilding the full key. This reduces single-point compromise and supports institutional controls like policy approvals, geographic separation, and recovery. The trade-off is operational discipline. Backups, availability, vendor risk, audits, and recovery all need careful design. In a multisig wallet, a transaction begins as a proposal, not an immediate spend. Each authorized signer reviews it and adds an approval with their own private key. Once the required threshold is reached, such as 2 of 3 or 3 of 5, the wallet logic allows execution. That logic is usually enforced on-chain, often by a smart contract. The result is strong visibility and auditability, but also exposed signer policies, extra gas costs, and contract risk. Smart contract wallets shift the account from a key-controlled address to a programmable policy layer. Instead of asking only, "Does this private key sign?" the wallet can ask, "Is this transaction allowed under our rules?" That enables approvals, role-based permissions, spending limits, time locks, recovery guardians, and emergency pauses. The trade-off is complexity. Security now depends on contract code, upgrade controls, module configuration, and chain support. Treat the wallet as critical infrastructure, not just a user interface. With HSM-backed custody, private keys are created and used inside hardened infrastructure, not exposed to business applications. Requests pass through policy controls first: role-based access, approvals, and often multi-signature authorization. The HSM or cloud KMS then performs the signing operation, while audit logs capture who approved what and when. This design must account for chain support, signing throughput, backups, high availability, and disaster recovery, because custody is both a security function and an operational function. Strong custody depends as much on governance as on cryptography. Key ceremonies make sensitive actions repeatable and controlled: creation, activation, backup, rotation, and destruction. Segregation of duties ensures no single operator, administrator, or system can move assets alone. Approval workflows should separate the requester, compliance reviewer, approver, and signer. Every step should also leave evidence: who approved it, what was signed, when it happened, and which policy controls were enforced. Custody selection should be treated as a structured architecture decision, not a preference. Start by identifying who needs custody: issuers, institutions, admins, operators, market makers, or retail users. Then classify the transaction: issuance, transfer, settlement, treasury, or emergency recovery. For each combination, weigh security, control, recovery, compliance, cost, and integration effort. Finally, document the chosen pattern, assumptions, risks, and compensating controls so regulators, auditors, and business stakeholders can understand the decision. Custody design is never one size fits all. Each model shifts control, liability, recovery, compliance, user experience, and integration effort. MPC, multisig, smart contracts, HSMs, and key ceremonies are the operating controls that make the model work in practice. Next, we go deeper into key lifecycle and transaction signing, then vendor evaluation and wallet security.